Now, we'll delve into the key aspects that set these models apart, which are parameters, architectures, pre-training size, and much more. Let's get started. So before we dive into specific models, let's define some key concepts that will help us understand the differences between these LLMs. So the first key aspect is parameter. These are the weights and biases in the neural network that the model learns during training. They determine how the input data is transformed through the network layers to produce the output. In simple terms, more parameters generally means a more complex model that can capture more intricate patterns in data. For example, GPT-3 has 175 billion parameters, making it one of the largest LLM in terms of parameter count. More parameters can improve a model's performance, but also require more computational power and memory. So next is architecture. Architecture refers to the design and structure of the neural network, including the type of arrangement of layers. Different architectures are suited for different tasks and can significantly impact a model's efficiency and performance. Take BERT, for instance. BERT uses a transformer architecture with bidirectional attention, allowing it to consider the context for both directions in a sentence. This is different from GPT-3, which uses a unidirectional transformer architecture. Now, let's talk about pre-training size. Pre-training size refers to the amount of data used to train the model before it is fine-tuned for specific tasks. Large pre-training datasets generally lead to better performances as the model learns from a wider variety of examples. For example, Google T5 model was trained on C4 dataset, which contains over 750 GB of clean English text. This extensive pre-training allows T5 to perform well across a range of tasks. Let's start with LLaMA. LLaMA was developed by Meta AI. LLaMA, or Large Language Model Meta AI, is designed to be highly efficient. It has about 13 billion parameters, making it smaller than GPT-3, but still so powerful. Its architecture is optimized for running on smaller hardware setups without compromising performance. LLaMA was pre-trained on a diverse dataset collected from the internet, ensuring a broad understanding of language. Despite its smaller parameter count, it performs very well, thanks to its efficient architecture. So this is the architectural diagram for LLaMA. We'll explain it in later sessions, but now let's consider that it is very optimized for running on smaller hardware setups without compromising the performance. Next we have Grok, developed by Baidu. Grok's architecture is tailored to leverage Baidu's vast data sources, integrating deeply with their search engine and AI services. It uses around 10 billion parameters and is optimized for natural language understanding and information retrieval like we understand in the last video. Grok was pre-trained on a massive dataset from Baidu's own search data. So this is a screenshot of Grok AI. A question was asked that was the 2020 US presidential election stolen? And Grok has wisely answered this question. We'll be covering Grok in later series. GPT-4 is the latest iteration from OpenAI, boasting an impressive 200 billion parameters. This increase in parameters allows GPT-4 to understand and generate text with even greater accuracy and coherence. GPT-4's architecture built on the transformer model, incorporating improvements in fine-tuning and context understanding. It was pre-trained on a vast corpus of internet text, ensuring it can handle a wide range of topics and tasks. So this is a model size comparison of all GPT models, starting from GPT-1 to GPT-4. First column tells about parameters. So you can notice that GPT-1 was trained on 117 million parameters only, while GPT-4 is trained on 1.76 trillion parameters, and there are 120 decoder layers. The context length is 8,000, while hidden layer size is 20,000. You can compare between all the models. Google Gemini is designed for versatility. It has about 11 billion parameters and uses a hybrid architecture that combines the strengths of different model types. Gemini excels in tasks like translation, summarization, and even code generation. It was pre-trained on extensive multilingual dataset, enabling it to perform well across various languages. Its architecture allows for efficient multitasking, making it a valuable tool for diverse applications. This is the interface of Gemini AI. You can select any prompt or even ask another in this section. If you click on this prompt which says explain how something works like an engineer and give this to Gemini, it will generate an answer within seconds. You can read that. We will be covering Gemini in a complete series in upcoming lectures. BERT was developed by Google and it has around 340 million parameters. It uses a bidirectional transformer architecture, allowing it to consider the context from both directions. This makes BERT particularly powerful for tasks that require deep understanding. BERT was pre-trained on the book corpus and English Wikipedia, providing it with a rich understanding of language. Despite having fewer parameters than some newer models, its architecture allows it to receive high performance on many NLP benchmarks. So this is the architectural diagram of BERT. We'll be covering it in detail in the upcoming sections, but for now, you can understand that it has a bidirectional approach. It has an encoder and a decoder. Mistral, a mixture of experts model, uses multiple submodels or experts to handle different parts of a task. It has around 15 billion parameters and combines the strengths of various submodels to deliver superior performance. Mistral's architecture makes it particularly effective for complex, multifaceted tasks where different types of expertise are required. By integrating specialized experts, Mistral can deliver highly accurate and comprehensive results across diverse tasks. This is the interface of Mistral AI. You can type anything here and it will give an answer within seconds too. So let's type talk about AI and it will generate an answer. It says, sure, I'd be happy to talk about AI. AI or artificial intelligence refers to the development of computer systems that can perform tasks that usually require human intelligence, and so on. So it has produced a very relevant and very efficient answer in a very less time. And that's a wrap up of our detailed exploration of the differences between various LLMs. We covered key concepts like parameters, architecture, and pre-training size, and saw how these factors differentiate models like LLaMA, Group, GPT, etc. Each model brings its unique strengths and innovations to the table, advancing the field of natural language processing in different ways.